everyone, my name is Shikha Jain and I am from Department of Computer Science and Engineering, KIET Group of Institution. Today we will talk about minimization of finite automata. What is the meaning of minimization of finite automata? Basically, in this particular topic we will reduce the number of states in a particular automata, right? So what we will do, we will minimize the automata so that the output generated automata will be equivalent to the input automata. So first, before going through this topic, minimization of finite automata, I'll tell you about unreachable states. What exactly is unreachable states? So when I'm taking this example, in this particular example, unreachable state is the state which has only outgoing edges. Only outgoing edges. No incoming edges is there for a particular state. So just like in this particular A state, we have outgoing edges as well as incoming edges. In this also, in this also, in this also we have outgoing and incoming edges. But for particular E state, we have only outgoing edges. Outgoing edges, just like it is outgoing edges, and E, this self loop is also an outgoing edges, because the self loop will not make it to reach the final state, because we have D as a final state. So it will not make it to reach the final state. So we can say that no incoming edge, only outgoing edge, and cannot make it to reach the final state. So E, this self loop will not make it to the final state, so we can say this is the unreachable state. So in this minimization of finite automata, we will remove this unreachable state first of all. After that, we'll start the process of minimization, right? So this is first example. Now in this particular example, we can say that Q5 and Q6 are unreachable states. Why? Because in Q5 also there is no outgoing edge. It has some incoming edge, but it will not make it to reach the final state, because there is no outgoing edge which will lead to reach the final state. So this Q5 and Q6 is of no use for us. There is no use of Q5 and Q6. So we can say it is a dead state. Q5 and Q6 are dead state. So this is an example of unreachable state. This is an example of dead state, because they are of no use and it will not make it reach to the final state. Now we will move on forward to the minimization question. So we will minimize this particular automata. So first of all, we need to identify what is the unreachable state in this. Which is the unreachable state? So by going through the particular diagram, only Q6 has the outgoing edges. There is no incoming edges coming towards the Q6, right? So Q6 is the unreachable state. So we will remove this Q6 state before proceeding towards the minimization process, right? So in this particular example, we will remove the Q6 state. We will just need to write that Q6 is the unreachable state, so we will remove it and then we will start the minimization process. So first of all, before starting the minimization process, we need to make the transition table of the diagram, of the state diagram. So start with the transition table. We have Q0 as an initial state. You have Q1, we have Q2, we have Q3, we have Q4, we have Q5. Wherein Q3, Q4 and Q5 are final state. So we have make a circle on that. And we have the input alphabets as A and B. So Q0 will make a transition after taking A as Q1. Q0 after taking B as in transition will move towards the Q2. Q1 will make a transition on A as Q3. Q1 will make a B transition as Q4. Q2 will make a transition on A as Q3. Q2 on B as Q5. Q3 on A is self loop. Q3 on B is Q1. Q4 on A is Q4, and Q4 on B is Q5, and Q5 on A is Q5, and Q5 on B is Q4. This is the transition table we have made from this particular diagram. So we have come up to the first step, removing the unreachable state. Next is make the transition table, and then we will make pi naught as a set of all the final state and all the non-final state set. So what is the final state set? Final state is Q3, Q4, Q5. These are the final states. What is the non-final state? That is Q0, Q1 and Q2. This is the non-final states. So now, how we will do the minimization process? We will first make the finals and non-final set. After that, we will make pi 1, and this is first I am writing Q3 from this. I am writing Q3. Now I am comparing Q3 with Q4. Compare Q3 and Q4. Q3 and Q4 with A transition as Q3, Q4. It belongs to one set. And Q3 and Q4, B transition is Q1 and Q5. Q1 is here and Q5 is here. So they are not equivalent. So Q3 and Q4 will make different sets. Next is Q3 and Q5. Q3 and Q5 will A transition is Q3 and Q5. Q3 and Q5 will belongs to one set. Next is 1 and 4. They are belongs to 1 is here, 4 is here. This is one is final, the other is non-final. So it will not be equivalent, right? So Q3 and Q5 will not will not be equivalent. So Q3 will makes it single state. Now we will check Q4 and Q5. Now Q4 and Q5 will belongs to one set, final set. Q4 and Q5 in here it belongs to same set, Q5 and Q4, right? So we can say that Q4 and Q5 will belongs to one set, right? Next, non-finals, we will same the process. Q0 with Q1, Q0 with Q1, Q1 and Q3. Q1 is here, Q3 is here. They are not equivalent. So we will not use Q0 and Q1 in the same set. So it will be Q1. Now Q0 and Q2, 1 and 3 are not in the same set, right? So we will not make it in the same set. Now again we will check Q1 and Q2, Q3 and Q3 will belongs to one set. Q4 and Q5 will also belongs to one set. So Q1 and Q2 are equivalent. So this is pi 1. Pi 1 is generated from the pi 0. Pi 1 is generated from the pi 0. Now we will do for pi 2. Now our sets is these sets. We have previously we have 2 sets only. Now we have 4 sets. So now for pi 2, for generation of pi 2, we will consider these 4 sets, not the 2 sets, right? So pi 2, Q3 is single, Q0 is single. Now Q4 and Q5, Q4, Q5 will belongs to one set, Q5 and Q4 will belongs to one set. Remember one thing which is very important in this case is when we are comparing, so we will compare only A transition among each other and we will compare B transition among each other. Don't compare all together all the 4 transition, okay? So Q4 and Q5 are in the same sets in pi 2 also because the transition are same, 4 and 5, 5 and 4. Now Q1 and Q2, Q3, it belongs to one set. 4 and 5, it belongs to one set. So Q1 and Q2 are also belongs to one set, right? So when pi 1 is equivalent to, because when pi k is equivalent to pi k minus 1, we will stop this process of minimization. Here also pi 1 and pi 2 are equivalent. Pi 2 is equivalent to pi 1. So we will stop this process. So the final states are, so the final output is this. We have only 4 states. Out of 5 states we minimize using the 4 states. So now I'll make the diagram of these 4 states. Q0 initial state, Q3, Q1, Q2, and here it is Q4 and Q5. Q5, right? What is the final state? Q3 is the final state, Q4 and Q5 is the final state, right? Rest all things like this. Q0 with A is Q1, so it will go to Q1, Q2. So transition and Q0 with B is Q2. So it is A comma B because Q1 and Q2 are all together. Now next is Q1, Q2 with A is Q3. We can check it here. Q1, Q2 with B is Q4 and Q5. Q3 with A is Q3. B is Q1, Q2. Because it is Q3 with B is Q1. So it will reach to the Q1, Q2. Now Q4 and Q5 with A, it is Q4 and Q5 and B is also Q4 and Q5. Right? So this is the final minimized state diagram of the particular automata. One thing you need to check here also, there will be no dead state. Dead state is something which has only incoming edges. No outgoing edges is there, right? So there is any dead state is there, there is no dead state. Because it contains no dead state, so this is the final output automata. If we have some dead state, we need to remove that too. Okay, thank you.